In this lesson, we're going to talk about parent functions and how functions have different families, and how are all these families unique from one another. So let's start with some basic vocabulary. So first, we're talking about functions. That's going to probably be all of our favorite F words by the end of this year's function. A family of function is a certain type of equation. So you could have quadratics, you could have absolute value. All of those will have a certain thing that makes them unique in their equation, and all of those are going to make the same shape. They may be shifted around or stretched or compressed, which we'll talk about in the next lesson, but they're all going to make the same general shape. And each family has a parent function, or if you're feeling a little wild, you can call it a mother function. Um, and that's just the most basic type of equation that you can have in a family. Um, all of these are going to have different attributes or characteristics, which define how they're different from one another. Increasing intervals are whenever the x value is increasing, or y is also increasing, so it's going up. And decreasing is just the opposite, y values are going down. The end behavior will describe what the function does when it goes off forever. So like, what direction are we traveling in? First parent function we're going to talk about is the linear parent function, which is also the most basic type of equation that we can have overall. The equation for the linear parent function is y equals x, and I see it makes this straight line. If we want some points that we can graph, we can come and click on the settings, and then you can create a table. And you've got some points that you can plot and graph on your graph. So the domain of this, how far left are we going? Well, we never stop going left. I could zoom this out forever, and it's never going to stop. So I'm going left to negative infinity. And then same for the right. There's nothing ever stopping me going right, so I go right for positive infinity. Range is exactly the same thing. My left is going down forever, so negative infinity. And when I go right, I also go up forever, so that's going to be positive infinity. My increasing interval is where is the y value increasing? And I see on this graph here, every x value has a higher and higher y value. So my increasing interval is actually all real numbers. And to write that, we can do this r with two lines. That's our mathematical way of writing all real numbers. The decreasing interval, there's none, because there's no point on the graph where the y value is increasing while the x is increasing. My end behavior. First, we're going to look as x approaches negative infinity. So negative infinity would be going to the left, right? As I'm going to the left like this, I see that the y values are increasingly getting smaller. And so I'm going to say this is going to go to negative infinity as well. Just like that, when we go to positive infinity, when x is going to positive infinity, as we're going this way and this way, I see that the y value is increasing as well. So we're going to say this also goes to infinity. The next function we need to talk about is the absolute value parent function, which we kind of looked at in the last unit, but it's y equals the absolute value of x. It's the most basic type of equation that we can have. Again, you can click on the settings and create a table if you want to see some points that you can plot. So my domain, I see this graph is never stopping going left, so I'm going to go left to negative infinity. And then same for the right, there's nothing stopping me there, so I'm going to go right for positive infinity. My range, however, I do have a lowest point right here at 0, 0. So I'm looking at my y value. That's my lowest point on my y-axis, so I'm going to put a 0 and then put a bracket around that because I do have a closed circle at 0. After that, there's nothing stopping me from going up, so I can go up to infinity and use a parentheses around that. For my increasing interval, I see once I pass this lowest point here, all of these y values on this graph are increasing as my x is increasing. So my increasing interval is going to be all of the x values that are greater than 0. Or if we want to write that in interval notation, it would be from 0 to infinity. Everything is going to be increasing. My decreasing interval, well, I see that all of these have the y values getting smaller as the x is getting bigger. And so my decreasing interval is just the opposite. It's going to be all the x values less than 0, or from negative infinity to 0 with a, actually, these would get parentheses because at 0, we're not really doing anything. It's just a point. So it'd be parentheses 0 to infinity and 0 parentheses, okay? My end behavior, as x goes off to negative infinity, that's going this way. I see my y value is increasing forever. So my y value is going to go to positive infinity. Whereas on the other side, as x goes to positive infinity, well, y is still increasing forever. So it's still going to go to positive infinity like that. Next up is the quadratic function. The quadratic function is y equals x squared. Makes this U shape. And so let's go ahead. Well, if you want some points, you can plot those points there. But let's go ahead and find the domain. Again, there's nothing stopping me going left, and there's nothing stopping me going right. So once again, my domain is negative infinity to positive infinity. Again, my range, I do have a lowest point. Again, it's at 0, 0. The y value there is 0. There is a closed circle, so I'm going to use a bracket. Then I'm going to go up to positive infinity afterwards. My increasing interval is again the same. After I cross this lowest point right here, all of my y values are increasing with my x. So we're just going to write an interval notation this time. It's going to go from 0 to infinity. All of those y values are going to be getting bigger. But again, at 0, we're not doing anything specifically. That's our turning point. So everything that's just past 0 is going to start increasing. So I'm going to use a parentheses around 0 and a parentheses around infinity. My decreasing interval is just the opposite. It's all of these values over here. And so I'm going from negative infinity to 0. We're getting really close to 0, but at 0, we're staying still. So it's going to get a parentheses. As x goes to negative infinity, so as x goes this way, I see that my y values are increasing. So it's going to go to positive infinity. And same with my x values. As the x goes up this way, these are also going to go to infinity. And last but not least, we need to talk about the exponential parent function. The exponential parent function is when x is an exponent. So we can say y equals 2 raised to the x, and that can be our most basic type of exponential function. And so now the domain, I see that there's nothing stopping this purple graph from going left. So I'm going to say it goes again to negative infinity. There's also nothing stopping us going right. We're not going right very quickly, but there's nothing stopping us. So it's also going to infinity. The range gets a little more tricky here because I see that this graph is flattening out really. Maybe I can change this to red so that we can see it a little better. As I come down here, I see that my y values are getting really, really close to 0, but we're never actually reaching 0. And so what we're going to do is we're going to use that parentheses. So my lowest point is 0, but I'm going to use the parentheses around it to say that we're never actually touching 0. We're just getting really, really close to it. After that, obviously, we see that this graph is going up forever. So it's going to get a parentheses like that. My increasing intervals, well, I see that my y value is always increasing while my x value is increasing as well. So again, my increasing interval is going to be all real numbers, and I'm going to have no decreasing intervals. As x goes to negative infinity, I see that the y value is getting really, really close to that same number 0 that we talked about. So as x gets further to the left, I see I'm getting closer and closer to 0. So that's going to be my end behavior, is y is going to get really, really close to 0, even though we're never actually going to touch it. As x goes to positive infinity, though, I see that this graph is going to keep going up and up and up forever. So I'll say that f of x goes to infinity. And those are our 4 parent functions that we're talking about right now. I hope you had as much fun as I did, and I'll see you mother functions later.